All right, everyone. Thanks for coming. And I'd first like to start out, well, I'm Nick Schrock. I'm a software engineer at Facebook. But I first want to mention thank you very much to the New York react.js meetup for organizing this. As always, I'm really impressed with the React community, the passion of the community, and also your ability to show up to meetings on short notice. So this is awesome. Yeah, and they wanted me to note that there's also going to be hopefully another awesome talk next month about React Native in production. So without further ado, what I'm going to talk about today is GraphQL. What is it as a system? Kind of how does it fit in with the general ecosystem? How does it compare to other technologies you might have used? As well as how it kind of fits into all this stuff that Facebook is releasing. You know, we're releasing all these different projects. And it's kind of interesting to think about how this is all coming together to be like a cohesive platform for mobile development. So let me fix this for a second and get rid of that one. Excuse me, this has got to reset here. All right, great. So the story of GraphQL starts about 4 years ago in 2011. So you know, in 2011, that's when Facebook really decided to get serious about mobile. Before 2011, we had these incredibly small, isolated application teams. In fact, the iOS app was started by this one guy named Joe Hewitt. He pretty much wrote it by himself. He just like built custom endpoints, but the app kept on falling further behind. You know, and it's also important to note that Facebook was really born as a website. And the web and all of its related technologies are just deeply embedded in our culture. So when we decided we needed to invest in mobile, make mobile our primary deliverable, really make it match feature for feature with the main website, we decided to go with a hybrid approach. We decided to do HTML5 in the native view. Now we thought this was going to be a best of both worlds scenario, where we have one developer set, they do cross-platform stuff, and then we can hop down to native, have with like a bridge thing within a web view, and you have notifications and whatnot. Well, this didn't really work out the way we wanted, right? It did accomplish the goal of achieving feature parity with our website with a limited number of engineers. It was actually a pretty impressive engineering feat. But we went from all of our customers complaining about lack of feature parity to our customers complaining about the apps being unbelievably awful. This wasn't really a transition that we wanted. Zuck famously said that this was probably the biggest mistake he's made in the last 3 years, kind of allowing this approach to go forward. Mobile web browsers simply couldn't handle the complexity and scale of our apps. The mobile web browser, I mean, you remember, it was awful. Slow frame rates, it would crash all the time out of memory. It was terrible. And it didn't help that the DOM is really at its core a pretty awful API. And it's really not the right API for developing high quality applications. So, I mean, you guys are all familiar with this. You want to abstract away the DOM into a virtual DOM, if you will. So at the beginning of 2012, we really started an effort to develop truly native applications of our mobile apps. We did a from-scratch rewrite of our native applications. Well, from our mobile applications to native applications. This was a de facto re-architecture of the entire Facebook software stack. So what do I mean by that? Kind of before this process, I would say the center of gravity in our product development was on the server. Right? Most of our engineers worked there. Their job was actually to fetch data and create markup, which was shipped down to the clients. With the shift to native apps, so much more of our capability, and really it became, we like to say the center of gravity shifted to the client. Most of our engineers went there, and really you kind of start with a mobile-first design parameter, right? And then you kind of work backwards to the data you need. It changes the entire dynamic of the engineering organization. And we knew with Facebook's scale and the number of developers we had, we were really going to have to develop an internal coherent platform in order to be successful. So we started with kind of a standard RESTful API. REST, there's many definitions of REST, and I don't want to get into an ideological food fight up here. So when I'm talking about REST, is systems that self-identify as REST. It's a very useful political dodge. But you know what it just generally is. It's like one HTTP round trip to get an endpoint that has this entity or a set of entities of a single type. And the issue with this as a mobile application is that in order to fetch a complicated object graph, you have to do a bunch of round trips, right? You start to fetch the user. There's like a link to their friends. It's a list of URLs. And you have to go get a bunch of, do another set of requests. And you have to build all this custom logic on the client to make it so the HTTP go in parallel, yada, yada, yada. For mobile applications that can potentially operate in adverse network conditions, this is just completely unacceptable. So what do? Well, what you do is you end up starting transitioning from REST endpoints to custom endpoints for your really important interactions, right? So you build custom code, it delivers exactly the data you need, and then you render it. Well, this has its own issues, right? As you deploy many, many, many versions of your app, it's very difficult to manage that custom endpoint because it's delivering to all different versions of the app. And then you start spawning dozens of them. Different teams manage different ones. They become inconsistent. There's really poor tooling around them. I mean, you know what I'm talking about. Every system that I've ever seen of any complexity just ends up being this continuum of like traditional REST endpoints for the stuff that doesn't matter that much, all the way to custom endpoints for like the mission critical parts of your application. And kind of more fundamentally here is the developer mental model of what's going on. When you're developing your views, you don't think in terms of, there's a single entity and has these resource URLs and yada, yada, yada. Nor do you think in terms of like table-based APIs, right? If you've ever developed a backend where you start off with a SQL table and then you have to like shuffle it into all these objects, or God forbid, use an ORM, that's like you don't start thinking about SQL. At least most developers I know don't. You start thinking about your view hierarchy, and then you have to be like, oh God, what SQL joins have to do this, and then you shuffle into objects. So what we wanted really to do is to create an API that was very congruent with the way that developers think about how they build their applications. Well, how do you do that? Well, almost all the views you ever build are hierarchical. They generally map to a graph of hierarchical data. So why don't you just start with that? And that was really the genesis of GraphQL. It's a query language that aligns with the way that product developers and designers think. It's a way to access your data. So this seemed to work. A few months after its conception, GraphQL was powering a newly built native newsfeed. And the apps were substantially less terrible, which was our goal. Really a high bar to hit, right? And that was about 3 years ago. Now, GraphQL powers essentially the entire surface area of the Facebook mobile ecosystem. Serves 260 billion requests a day, which is a lot. And it serves actually 1,000 active versions of our various applications, including the original one launched. So this is a real technology. And if you're a mobile developer at Facebook and you're doing anything to access the data that backs Facebook, you are interacting with GraphQL in order to do that. So I think a fair question is, what exactly in the hell am I talking about? You're saying all these words, but can you get down to brass tacks and show me this thing? Well, I like to introduce things by example, so here we go. So this is kind of the hello world of GraphQL. I want to query myself and my name, right? So the first thing you notice, the structure of this is actually pretty similar to JSON. Kind of like if you squint, look sideways, it looks kind of like JSON. So there's these curly braces, you have nested fields, and then fields themselves can have subfields. We call those selection sets. And so if you query this, you get back a response, fairly natural to look at. At its basic level, you send the string up to a server, it's parsed and executed, and this response is returned. So you see the response and the query have the same structure. The fancy word would be isomorphic. And this is an important part of why GraphQL is easy to learn and use. GraphQL query itself describes the shape of the responding data. So this can get more complicated, right? We can access things programmatically. You should actually think of these fields, conceptually they're just functions. Okay? They're a thing that takes parameters and then returns an object, and then you can operate on that object that was returned. So ID here is a field argument, and you just pass an ID, it passes an object. This is my ID, so again, it's me. You can also have complex values here. So here we're requesting me, and now we've added my profile pic, which itself has subfields with height and a CDN URL. And I bet you can guess what the response shape looks like. It looks exactly like the query. Right? So it's like a very natural way to describe your data requirements. And a lot of these fields can take parameters. For example, sometimes you want a bigger profile pic, so now you get a bigger one. With height 300, get back a CDN URL. So we have other features in this language. So imagine you wanted 2 different sizes of profile picture. You need to rename the keys so they don't collide in the response. So we have aliases, right? It's very simple. Little pic, big pic. They describe the 2 different response keys and the different responses. So where it gets more interesting is that GraphQL was not designed just to get the properties of a single object, right? It's also designed to smoothly follow the connections, to smoothly explore the object graph that you're interested in, right? So here, we're querying not for just my name, but the list of all my friends and their name, right? This is contrasted with the REST approach where you would get a list of URLs, and then you need to go and get the subsequent data. You need to go to the subsequent data in different round trips. So, and you can do this as deeply as necessary, right? So once you get down to friends, it's just another user object. And on that user object, you have access to all the fields that we defined there. And you can go arbitrarily deep as you want. So you've seen kind of the moral equivalent of hello world in GraphQL, and it seems like a fairly elegant language, but it's more than just a data query DSL that looks good on slides. GraphQL as a language is powerful because it models data requirements in the way that product people think, or that's what we claim. It's easy to imagine what the resulting data looks like just by the look of the query, and it's straightforward to know what data you need. But what else is it more than that? Well, at the core of GraphQL is a type system, which you define, that expresses all the capabilities of a GraphQL server. So here's an example GraphQL query. I'm going to get me, my name, profile picture, and my friends ordered by a thing called importance. And so let's just go down this as we descend down the type system. So at the root of every single GraphQL schema is a special type that's like the root query type. Right? So just like a singleton type that describes all the routes by which you can explore the graph. So here we have me and user. We decide to use me. So me returns a user object, and now we have the different fields we can query on this. So this example shows a couple principles. One is that I think the order by is particularly interesting because it shows that there is no actual field called importance on this object. Importance is just an ordering that's defined in software. In reality, this is kind of the thing, when you're typing on Facebook or using the app, it just happens that the same people pop up again and again and again. And it's dynamic over time. That's a system that we have with machine learning and big data and all the rest of it that determines who are your closest friends. So here we're ordering by importance, right? And it's our middle tier that does the orchestration of fetching it from that specific service and then doing the sorting there and returning it back to the user. And then you'll see we have this enum where we explicitly whitelist the orderings that the server will support. So we don't just allow you to pass in any string, because when you have like 3 bajillion servers like we do, sharded across user ID, you can't just offer arbitrary orderings, because you'd be incredibly inefficient without indexing. So we, in our style, in our conventions, we whitelist stuff. As we descend down, we get a profile picture, the profile picture field. It has width, height, and URL. And then again, out of friends, we get back to the user object, right? This is a fully generic type system that you can explore. And then here, we actually just get the first event. So as you can see, this is how you kind of descend down a query. And it's strongly typed at every step on the way down. If you send an incorrect query with a mistyped field, it'll spit an error back at you. So again, the mental model here. In typical applications, an app server kind of owns the models, and then mobile applications request those models based on ID. So this is kind of a traditional web server, REST server, pardon me. But the interesting thing is what happens as your app evolves, right? So you create a new view. And then what happens when you create a new view? Well, it has different data. Well, you go to the server, and you change some stuff on the server so that you have v2, right? You generally have to iterate these things in lockstep, right? This is like a coupling we actually do not want. So the dynamic in GraphQL is different. In GraphQL, the server expresses the possibilities of what you can possibly execute through the type system, and then the client expresses its data requirements with a GraphQL query. And this dynamic is actually quite superior in our opinion, and it's served us incredibly well, because effectively you've now changed from iterating the models. That's again, if you haven't added data which hasn't been accessed anywhere else in the entire application, but just imagine as you're changing your views, you're iterating models and views on the client. And this actually makes it far easier to manage backwards compatibility. So it's this dynamic that actually allows Facebook to serve a multitude of applications. But what's really interesting about this is that for each one of those applications, we have dozens of versions extant in the field. Right? Facebook now releases its iOS app weekly. If you're really mad about downloading the app, I apologize. But it keeps the new features and the best features in our users' hands at all times. But what this means, if you think about it, we're basically committed to supporting all these versions forever. So that means there's 52 versions of the app being created every year. And that's if we don't really screw it up and have to do a hotfix or something. So there are thousands, I think there's over 1,000 active versions of all our various apps out there. And as far as I know, they all work. And the dynamic of GraphQL actually makes it easier to manage this. So another important principle in GraphQL is that of composition. So as these apps get large, having a single query to describe entire interactions becomes untenable. So for example, our newsfeed query in our main app has on the order of thousands or even tens of thousands of fields, which is insane, but trust me, it's true. And so we have a unit of decomposition called a fragment. Fragments are as core to GraphQL as functions are to programming languages. Right? It's our primary unit of decomposition. So we actually steal the fragment reference sigil up there. It's just like the JavaScript spread operator, kind of similar semantics. So it's a little homage to JavaScript. And the ability to compose queries like this is actually just essential to managing complexity. And this is kind of how we align this with UI frameworks. Typically, when we construct our UIs in or out of Relay, we have our entire Android or iOS apps, which is not built in React or Relay. There's typically a one-to-one correlation between these fragments and views. Right? So if you have a view, you manage the fragment, and hopefully you keep them in sync. And then together, you compose the entire query and build it and send it all in one, send it to the server in one big chunk. Another important principle of GraphQL is that it's backed by arbitrary code. It's not tied to a particular backend. It's not tied to a particular storage engine. And let's put this in context of how we originally developed it, right? So we originally developed this to deliver newsfeed. And our newsfeed product is incredibly complex. So we have a feed ranking and storage engine. This is where like the auction happens. It interchanges the organic content, the ads, and it determines which stories are most important. And it's actually incredibly complicated, and there's a huge team that supports that. But that only sends back a list of IDs, right? Essentially like a rank-ordered list of story IDs. And then you have to get all the human-readable data out of our user databases. And then we have we have gobs of services, right? And so we had existing application code which orchestrated all this, right? You know what I'm talking about. There's a middle tier. And so ditching that investment and all those abstractions, all that code, is just like completely unrealistic. So GraphQL is a layer on top of your application code. That means it's not a storage engine, even though it has the words QL in it. We get feedback that's confusing. It's a query language over your application code, not a particular storage engine. So it can query over arbitrary code. That means that GraphQL queries can operate over your existing code. You do not have to ditch your existing code to adopt the system. What you do have to do is you have to adapt your code to the system. And that's done via our type system. So if you look at our JS reference implementation, we have all these type definitions, which kind of map each one of those fields to arbitrary functions, right? Arbitrary code that does stuff. And so let's kind of look at the example in pseudocode. So here we have a type definition of a simpler user. And here we kind of have 3 different examples of ways you would map this to arbitrary code. right? So the first example just maps to a simple property. Okay, well, that's easy enough. Well, imagine a profile picture. You can imagine just poking at some configuration. It has to construct a CDN URL, so this takes code. You need code, right? So it maps to this arbitrary function. And a really interesting aspect of this, which I'm not going to dig into, but is that our GraphQL engine internally is deeply tied to our asynchronous primitives, which means there's this inherent parallelism in any GraphQL query, right? Because it's a tree. And as you descend down the tree, there's an opportunity to execute things in parallel or concurrently. And we do this in our JavaScript reference implementation. This friends example returns an array of promises. And then it's up to what we call our executor to actually arrange all this. In very concrete terms, for JavaScript people who know the promise API, which is brutal to deal with, that's the thing that calls promise.all. Right? So it's that centralized component that manages all this concurrency and allows you to kind of express each one of these individual fields in far simpler terms. We actually find this to be an incredibly useful aspect of GraphQL internally. We're able to centralize our complexity so our Leaf programmers who work on product, want to think about product, don't have to think about these complex interactions as much. So we've talked about the type system in terms of its usefulness and just kind of executing queries, making sure they're safe, so you know that you're not mistyping fields as you go along. But where it gets really useful is actually when you're modeling stuff on the client. So we actually have the capability of externalizing our type system. So we needed a way to get this information out of the GraphQL server, and if we only had a way to query structured information on the server, well, you can query the type system using GraphQL itself. We're very proud of this. The fancy word is homo-iconic, which I don't really know what it means, but I've been told that it's really fancy. But essentially, every single GraphQL server has to expose a top-level field called Schema. And from this query, you can query the type systems. You can get the fields, you can get the documentation, and all sorts of meta information. And so really, it's a really powerful platform for building tools. And so this is just a few examples of what you can do with this, right? You could build documentation browsers. You could do code gen, right? So you query the server, you get all the type information, you use some code gen. This is very familiar to anyone who's worked with like protocol buffers or, God forbid, SOAP. If you want some PTSD in computer programming style, you could code gen Flow. But the real star of the show here is a tool called Graphical, which I'm going to demo for you here. So I'm going to put this in the context of moving from REST to GraphQL. So there's an existing REST API out in the wild called Swappy, the Star Wars API. So you can query information about Star Wars. And it's kind of meant to be a REST showcase, right? So it's very nicely documented, kind of follows REST patterns. And you know what this looks like. There's like a little toolkit where you can type in a URL, you can get responses. And then you have documentation, which is maintained out of band. And then when you want to navigate down the object graph, you get a list of URLs. And you have to do another round trip to grab them. Is this looking familiar? This is every REST API you ever dealt with. So what does the GraphQL version look like? So you can imagine actually building a server-side implementation of this, where the mobile client sends up a GraphQL query, and then our engine actually does a sequence of REST requests within the data center, right? So this would actually be a pretty reasonable way to introduce it to an existing organization. Let's imagine you don't want to convince the server people to do anything. You don't want to touch anything. You just grab a box in your own data center, and you have it process GraphQL queries, and then it chattily talks to the REST endpoint. And that's better than doing that over the public internet, right? So what does this look like in GraphQL? I couldn't help myself. I need to make that better. So here we go. Oh, this got all messed up. Great. 1 second here. All right, so we're going to make this bigger too. Is that big enough? Can we see this? OK. So in the previous world, right, you're navigating on a website and you're going through all these toolkits and expecting what's going on. In the GraphQL world, you do this, and you have a type ahead, right? And this type ahead has integrated documentation. So let's go down the starships here. Go down, get starships, some of the, get the name. OK, that's cool. Well, let's see, what's this? Maximum speed of the starship in atmosphere. Null if it's incapable of atmospheric flight, right? How much nicer is this than like dealing with like 3 web screens and doing all this crap, right? Everything's right there. It's an IDE for your servers, right? This is awesome. Well, I think so. This is the thing that actually kind of sells the system. When you're like looking at like, oh, well, platform building tools, what does it mean? It's like, that's what it means, right? Magic type aheads everywhere. It's phenomenal. OK. I'm getting too amped up here. But the other nice thing you can do here is you can actually kind of change the type system, right? You can clean stuff up as you're doing this. So in the public API, you have this manufacturer thing, right? You read it, you're like, oh, it's comma separated if there's more of them. Oh, that's cute. So now on every single client, you have to process this. You have to split by string. It's just annoying, right? You've dealt with this. And so you see here's like, I think this is the Death Star. Apparently it's built by the Imperial Department of Military Research and Sinar Fleet Systems. But instead what we can do is just on our server-side implementation, right? This is just a snapshot of real code. We can get this response from the REST server, do a little processing on it, and then return it back. And then we can expose it as an array, right? Which is easier to deal with, model in the client, and the rest of it. Now we have that result. Right? So this is like the power of being able to back fields by arbitrary code. Right? You can clean stuff up, you can do translations, you can do all this stuff. We can continue playing in this. So let's get the manufacturers here. Right? You can go down here and like, oh yeah, there it is. See that? But this gets really exciting. Oh yeah. On the left here, what I'm doing is this is actually spitting out the REST requests that it needs to make. So in order to get this data, these are the equivalent requests you need to make. So let's go down here. Let's get pilot connection. So we have this connection deal, which actually returns meta information, right? So you can get like the total count of pilots, but then you can get the pilots themselves and get all their names, right? So now we get all the starships, all the names of all the pilots, right? And this is the number of REST requests you need to do to replicate this, right? Instead, 1 round trip. We also do pagination here. So you open this up, look at that. You have first, everything's a type ahead. It's great. Let's do the first 3 of these guys. OK, that's fun. And then it also catches errors, right? So let's imagine we did this instead. Oh, look, squiggly. Oh, look, exactly what the error was. Right? So this whole thing has like descriptive error messages. It catches mistakes before you make them, all the rest of it. So as we navigate these connections, right, we're doing lots of REST requests. And you can just keep on arbitrarily going down. So now we're back, and we're requesting all this stuff. Now let's request their home world and the home world's name. Right? Now we're requesting a bunch of planets. Now from the home world, you can go back, and I think there's like characters, something. Oh, let's see what we're at here. What's another fun one? Resident connection. OK, let's get the total count number of residents, get the residents and the name, and it does a whole bunch of crap, right? So you can see how natural it is to explore the object graph of your application. Now I'm going to demonstrate that fragment thing I was talking about. So let's get rid of the resident connection. So let's do a fragment. Let's call it the pilot fragment on. So even this has type ahead. It's amazing. OK, and we want to do name, home world, and name. And now we can replace, let's see here, this guy with the pilot fragment. Oh, unknown fragment. OK, there we go. Right? So you can see how you can like continue to decompose these queries and whatnot. This is like GraphQL is a critical tool that all of our developers use. So let's go back. So that's kind of our intro to GraphQL. What started as a tool for building our native newsfeed has really become a critical part that we build all of our applications. And now with Relay, how we want to build, externalize this to build the web, and with React native applications. And when we built it 3 years ago, we didn't really have, we had some ambitions about this, but we didn't really know how critical it would become and how integral it would become to the Facebook mobile developer experience. And we built it really quickly in a way that was pretty tightly tied to our internal infrastructure. So over the past several months, we actually made a bunch of improvements to the language. So the version that we're open sourcing is actually what we think is a evolved version of the language. And that is what we open sourced in July. Actually, one of our huge projects for this half is actually backporting the language changes into internal Facebook GraphQL. So in about 4 months or so, open source and FB GraphQL will be merged, and we'll iterate the ecosystem in lockstep. So the initial launch included an RFC specification, our JS reference implementation. Now we kind of have launched GraphQL out to the public. We've launched GraphQL Relay, Relay has kind of a very specific schema flavor that it expects in order to work. We've released an Express plugin for GraphQL that allows you to build an HTTP server quickly. LibGraphQL parser, which is a native parser built in C++, so you could embed that in other scripting languages and just build bindings instead of having to rebuild the entire parser. And we actually have open sourced that swappy demo as well. So you can kind of check out how this works in reality. So what's really exciting, though, in my opinion, is the external projects. So we've actually been very pleasantly surprised at the number of people who have kind of gone all in on this and have decided and really gone for building entire GraphQL engines in different languages on their own. Right? GraphQL is all about centralizing complexity, so that for the developer, it's pretty simple. You just go into GraphQL and start typing. Right? But in order to make that all sing, it's actually a pretty complex system. The specification. By the way, if I die without writing another specification, I'll be very content with that. I have a newfound respect for people who do that. But the specification is complex, and we have people implementing this. So we have a very real implementation in Ruby. We have one in Java. There's a company out of Finland they're super active in our community. They're building their startup on this, which is awesome and very brave. Admire them for that. And actually, the Financial Times is actually building the next version of their homepage on this already. So even though it's pretty bleeding edge, there's a ton of activity, and it's super exciting. We have 500 people in our Slack. It's actually active. Actually, we don't have to answer all the questions anymore, which is awesome. It's kind of this self-fulfilling thing. So, and we've actually launched GraphQL.org, so it's a huge step of having a website. And we're going to keep an index of the external projects and much more literate documentation and whatnot. So I want to step back in a second and talk about kind of Facebook's open source strategy in general. So we are open sourcing a ton of stuff, right? It's kind of hard to keep track of this kaleidoscope of different projects, right? What are all these logos? Can you even keep track of these? I can. I'm just reading off the slide. We have React Native, of course, Relay, Nuclide, which is kind of an IDE that's targeting all these technologies. We have Flow, which is our gradual typing system overlaid on top of JS, and on and on and on. And on their own, these are actually extremely useful projects. Right? They can work alongside many other technologies. But together, they actually add up to more. I like to say that the whole of these things is greater than the sum of their parts. Right? They all fit. And together, we really think that we're really kind of making mobile development and client development in general move forward 5, 10 years. And put this in context of the mobile revolution. So we've really experienced a complete revolution in consumer technology, right? We're all carrying around these cell phones. They're all supercomputers, right? It's 1,000 times more powerful than the computer that powered us to the moon or whatever, right? It's bananas, and they all have location information. They have connectivity. It's connecting people to social networks, communication networks, economic networks, right? Completely revolutionizing at least That's a little strong, but it's really changing the way that people live across the entire globe. Right? There's like 3 billion mobile users. It's freaking insane. So this has been a giant leap forward for consumers. Now, for developers and developer organizations, this has been like going backwards like 15 years. You have to develop in Java? Are you kidding me? This is ridiculous. Like you're stuck with these proprietary tool chains, right? Especially when compared to the web, right? The web was like the gold standard for product development, in terms of how your organization could behave. You can have one organization that does cross-platform. You're built on open standards. You don't have vendor lock-in to proprietary tool chains. You had instant distribution, right? So you could dynamically deliver code to people. You could run experiments. You could fix bugs instantaneously, right? If you ship a bug in client software, it's awful. You have to convince someone to reinstall something that previously sucked because of the bug, right? And then these things can live on and on and on. It's terrible. In the web, you just immediately fix the problem, repushed, and you're done. Really fast iteration. If you ever moved from a large web code base to a large iOS or Android code base, it's like you start to contemplate your career choices. It's terrible, right? You're sitting there waiting to compile, you get bored. You don't have this like instant feedback loop. It really kind of disrupts your flow in a Zen sort of way. You know? And then, kind of more subtly, this actually dramatically affects the way that you organize entire teams, right? So it used to be like a singular product team, right? One team, one purpose, one goal. But now, even in a small shop, right, you have like the iOS person and the Android person. Maybe they don't get along, or maybe they're in different cities. So then you have to hire a third person just to coordinate them. And then as you grow an organization, this gets worse and worse and worse. Right? In a large organization, you have to decide whether to organize, like at Facebook, right? We have unique problems, hashtag big company and all the rest of it, but we have to decide whether or not we organize our organization around platforms or products, right? You could have like an Android team and an iOS team. That ends up generally, the apps have better technical execution because there's kind of one centralized arbiter that maintains quality, but then the products get out of sync. Right? So the alternative is to organize around products. But then there's no centralized authority to manage the apps, and it turns into this tragedy of the commons deal where it can degrade quality. Well, this is a horrible choice. No one wants to do that. It was way better in the web days. You said one team, that was it, move forward. And Facebook has this fundamental belief that with the right tools and the right software and the right abstractions, you can really change this entire game. Right? It's not just about structuring classes better, writing unit tests. Like you can fundamentally change the dynamics of your organization. So one of the core elements of this open source strategy is React. And I have a bit about, for those who don't know what React is, but I don't think I need to go through that here. But those of you who don't know what React is, it's a JS toolkit for building UIs, right? And it's really nice. You go to one of these React meetups, it's like a church revival. Everyone loves it. I've really never seen a community so engaged with a software framework. It's amazing, right? And it's really been a spectacular success, right? It's taken the front-end community by storm. And there's a reason for this. React is opinionated about the way that software should be written. React has values, right? Believes in functional programming, mutable data structures, declarative APIs, and our favorite, rethinking best practices, right? Took a lot of best practices, kind of turned them on their head, right? You should always be aware and respect best practices, but you should not be hostage to them, right? So the big one, right, is JSX, right? We embed markup in our code, and everyone goes bananas, but then they end up always coming back. So the React team was brave enough to challenge best practices, right? And it kind of is demanding of users. Right? You have to align your head to it. And once you do that, you can build these. Again, I don't need to sell this to you guys. You guys showed up here. React is really opinionated about the way that software should work. But as you know, React is expanding. And we're building React Native. React Native is a way to build React applications on the native platforms. So it's been on iOS for a while. A couple weeks ago, we released it on Android. And you can potentially build it on any other platform too. And in this way, kind of the phraseology we're using and the way we're thinking about this is that this makes React a horizontal, opinionated platform, meaning that we don't seek to replace the entire stack, right? We're not building our own mobile OS. And instead, we're like overlaying what, if you think about it, is they're actually a relatively thin layer of software, but software that has opinions. And therefore, you can build unified abstractions, and you can use unified tooling. But you can still hop down and utilize the proprietary capabilities that customers demand, right? There's a reason why software engineering organizations were willing to contort themselves in order to deliver native apps. That's because customers have needs. They like things, and then we follow the customers. And this is what really distinguishes it from previous HTML5-based approaches. So again, you're probably familiar with these mantras, but just to be clear, we are not chasing a write once, run anywhere unicorn, right? You've heard that one before. It doesn't work. We actually think it's kind of a false idol. It kind of you end up making all these bad trade-offs. You end up going lowest common denominator, et cetera, et cetera. Instead, our mantra is learn once, write anywhere. And that kind of fits with this horizontal opinionated stuff. You learn the opinions, you learn the abstractions, and then you can write it anywhere across this horizontal surface area. GraphQL has these same values, right? It's a horizontal platform, has an opinion about the way that software should be structured, declarative, this one round trip, all the rest of it. But you can build this can be built on any language, right? And in turn, any storage backend. So you can use a language and storage backend that is tailored to the needs of your app, that's appropriate for your app, but then you overlay this kind of thin layer that sings to product developers. And again, in the same way, it's learn once, write anywhere. So Relay is really the first example of a software abstraction that really has bought into both sides of this horizontal platform, right? And as a result, again, I'm not on the team, so I can brag about it. Like, I really think that Relay is probably the best product-facing API that I've ever seen. You have the views and data right there, and they're right next to each other, and it makes sense, and then the centralized component orchestrates it all. It's pretty amazing. And because it's built on these horizontal platforms, it can target any of these proprietary client-side OSs, and it can talk to any GraphQL server that implements a spec. Right? It doesn't matter if it's JS or PHP hack or like Visual Basic, heaven forbid, or whatever. So this is working at Facebook. So we have this ads manager product. And ads manager products are actually really complicated. If you've ever dealt with ads products, there's like campaigns and ad sets and all, like, it's just nuts, right? There's like tons of, the data models are actually really complex. And the story behind this is that originally the ads team, they wanted to build a native iOS app, right? This is kind of the, you're like targeting like the social media kid who's at the bar, being like, oh, I need to buy more apps, buy more ads, right? This is a great revenue opportunity. And they budgeted like 18 months. They thought they were going to have to recruit like 12 iOS engineers because these things are so complicated. And then we, in our product infrastructure, it's kind of our broader group, we went to the ads people. We work with them a lot. They're early adopters of React. We're like, how about instead you don't do that? How about you bet on React Native, and we'll deliver this way quickly. You don't have to hire any new people because you have immense React, you have a ton of React experts on your team. And it turned out that a team that was like 5 to 7 engineers, I think only one of them had iOS experience, was able to build the app in 5 months. And then 3 months later, they built an Android app. The same team, delivering native experiences. If you're like in software management and you're not like shaking in your chair, like I don't understand. Like this is what we want, right? The best of the web, delivering these proprietary capabilities. It's insane. So we really think that, that this platform is our way forward. Now, we don't claim to have all the answers, and that's a lot of the reason why we kind of try to work out in the open, right? Like, we're not like releasing like a full stack platform like a Microsoft or Apple would, right? We're engaging with the community because you guys have different ideas, and we kind of want to make sure, one of the benefits of working on the open like this is that it makes sure that that we're not thinking crazy thoughts inside the Facebook asylum. You don't want the inmates running everything. So it's a good way to vet our ideas. But we really do think that with a suite of technologies, we can make mobile development just dramatically better. Yeah, so that's my talk. So thanks for coming. And then I think we'll have, I'll answer questions for 10 minutes or something. If you have questions, go to the mics, so they're recorded for posterity.
How do you deal with migrating, say, in the manufacturer example, from a singular manufacturer to multiple manufacturers to a manufacturer connection as that changes?
So essentially the strategy is not particularly elegant, but one key thing is that we built in deprecation to the system. So that means you can actually mark a field as deprecated, and then it disappears from all the tooling. And then effectively, you would start with a manufacturer field, and you're like, oh, wait, we can add manufacturers. You add that field, you deprecate the old one. And then you add manufacturer's connection, you deprecate the old one. So that means the reality is that you ship the client, right? Those fields are going to be around for a long time until you want to break the client. So the best you can do is hide them from future clients. And we attribute the type system with that so that squiggly lines show up or it doesn't show up in tooling or whatnot.
I guess as a follow-up, do you ever have issues with managing duplicate schema definitions between GraphQL and say Thrift for the same kinds of objects?
Not really, because they end up being in a different domain, right? So often they have, it's kind of like how, if you have a SQL table with a column called X, and then you also have an object with a property called X, and you just kind of manage it. So that's not really typically an issue.
Thank you. GraphQL and Relay are really awesome.
Thanks, man. Appreciate that. Go ahead.
Okay. In Facebook, do you have one big schema, or is there a way to combine different schemas and serve them all different?
So we definitely have abstractions for different schemas. So for instance, we kind of we separate our external-facing schema from our internal tools, because lots of our internal tools are built on GraphQL. And actually, there's been another effort to make it so there are separate schemas. We call them universes. So for instance, Oculus is building something, and they are using this system, and they use a completely separate schema. So we definitely have that. But in general, we do bias for these kind of big mega schemas that serve a ton of different things. The entire Facebook mobile app that you use is one big schema. Go ahead.
How do you typically get, if you have a large query, to use a HTTP post with the query in the body, and how do you do caching with those?
This is an excellent question. So the question is, you have these tens of thousands of fields. You might overload a query parameter in the get, and the answer is that we use a thing we haven't released yet in open source, persisted queries. So during the development process, we actually persist the query server side, and then in the app, we actually just emit an ID with parameters. It actually allows us to do really clever things. So for example, we can actually fit that into a single packet. So we actually speculatively launch a UDP packet when you load your feed, so that travels faster while a SSL connection is negotiating, and then pre-computes, and we cache it in memcache. So it allows us to do lots of fun stuff.
So the query is stored on the server?
Correct.
Hi, this is more of a clarification. You mentioned the type system, right? So the type system is defined by the owner of the backend data service, and the adapter to that data service is also written by the owner of the backend. And
Correct.
GraphQL is compiled to use the adapter written by the backend data service to do the querying, right?
Yes, that's, if I understood your
You
question.
understand the flow, yeah.
Yeah. So, effectively what you have, right, is that someone writes you have your existing application code, right? And we call this you can think of it as all your application types. And then essentially what your backend developers turn into, or your product backend developers turn into, is they turn into what we call GraphQL type designers.
Okay.
Right? So you map out your GraphQL types, and then your job is to map that to specific application code.
Okay.
Does that make sense?
Yeah, and your compiler compiles the GraphQL queries to use the mapping infrastructure.
Well, there's it depends on what you're talking about, the compiler. So server side, we don't have a compiler. Well, I mean, we have a compiler toolchain, I guess, because we lex and parse the queries, but it's not like a compiler that produces a binary. For our client SDKs, we have a compiler in that we evaluate the GraphQL queries and then do code generation. So then we generate artifacts, which are then compiled into our native apps, if that makes sense.
Okay, yeah.
Okay.
Thank you.
Hey, I'd like to know how you handle form generation. I know there is this concept of...
Handle what?
Oh, sorry. How you handle form.
Form generation?
This concept of a mutation, where you can actually post stuff to the server.
Yeah.
But like form can get tricky where you have nested fields, and then you also want the errors to show up in line next to the fields.
I see.
I was wondering if you built like a protocol or some sort of library to build that.
We have error reporting, but actually we haven't really used, I'm trying to think. I actually don't have a very good answer for that because I'm not a UI guy. I've actually never built a form in our apps. So I don't really know like how they structure that. I mean, we do have rich error reporting in GraphQL, but I'm actually not even sure if they use that effectively. So that's a good question. I'm not sure. Yeah.
So a lot of query languages have arbitrary aggregation and other related functions.
Yes.
What is GraphQL's, does it support it, or do you say, no, we don't do anything of the sort, you need to name your aggregations on? Can you just describe it?
Yeah. So it doesn't support aggregations kind of natively, shall we say. And that's an explicit design decision because it's effectively like too powerful, right? It's too easy to build like extremely complicated queries. Sometimes these aggregations don't even make sense on these computed fields. And it would be an excessive burden to make it so to implement those kind of operations generically across all of our data types. Now, there's nothing preventing you from adding specific arguments and fields that actually perform those aggregations under the hood. But it's always an explicit decision for the, what's that?
So you can have a named aggregation.
Yeah, but it's kind of a very specific design choice that we force the backend or middle tier developers to opt in and say like, I am willing to support this. This is a possibility I'm publishing to the client, and now they can consume it. We generally do not just kind of offer these like willy-nilly, you can evaluate any predicate and group by anything else, because this ends up being it's not a strict enough contract to be client and server in these mobile applications. That's our belief.
Thanks a lot.
A question about that graph server orchestration layer that kind of exists on top of the service of the REST APIs.
Yeah.
How much of that effort was spent having to go back to the API and actually having to change what was there, or how much of the effort was you discovered that the data was sort of held in these REST APIs, and it was just a matter of having to build the orchestration?
Yeah, so that middle chunk, the existing application code, the reason that we were able to produce GraphQL so quickly is that it was basically a direct externalization of a system we had before. So we had these internal systems called Ent and Ent Query. Ent was like our business object model that was kind of, and then Ent Query was a middle tier query language over that, and GraphQL was like a very direct mapping of that system.
So you weren't missing any data?
No, not really. That Ent and Ent Query had covered most of the surface area of the app already. Except for feed, so that was a big chunk of work to do. But the kind of like the framework and philosophy was there. So it is much easier to build a GraphQL server on top of a well-structured, middle tier code rather than just like this like goop that's everywhere. Does that answer your question? Okay. Yep.
Hi. Could you talk more about the relationship between the middle tier and the GraphQL server? As in, does the middle tier expose this model which is then the GraphQL queries and rearranges so that it replies back to the client? How exactly does that work? Or can the GraphQL server be the middle tier itself? Can I talk to the data?
So I mean, that's a super broad question. Can you like tighten up like what exactly like you're asking? Because I could talk for like 3 hours on that, and I have like 3 minutes, right?
Okay. As in, do I need a middle tier for GraphQL to work? As in, can I directly write my model logic inside my GraphQL server so it talks to the persistence layer and then exposes those via the GraphQL?
Yeah, I mean, if you have an existing model layer, right? You'd build your GraphQL server on top of that, right? And I guess maybe the question is kind of like what you would map the GraphQL types to. So typically, like in Facebook's internal implementation, every single field on a given type, like a type generally has a one-to-one mapping to an internal class, and each one of those fields maps to a single method on that class, right? And so we just kind of like stack right on top of our business object layer. Is that kind of, the whole structuring, we have like another hour talk on structuring the backends of these things. It's like, it's a pretty complicated system. Yep.
Probably a quick question, but is there, following up with somebody else, is there any way to do any kind of updates or mutation, or is it only for querying?
No. So we are doing a terrible job of communicating this, but the service area of the app includes the mutations. So and I actually should have added that to this talk, but so we talked about that root query type. There's also a root mutation type, and each field on that type corresponds to a single mutation. So because a field is just a function, right? That function can do a mutation, right? And then you can actually query data that you, the app developer, know that you need to get the data after the update, if that makes sense. And that's actually very aligned with Flux, right? So, where we centralize all our mutation logic, and basically, as far as I can tell, Flux is just like, hey, you should use a switch statement and call a function after each switch statement. But as a result, that spawned like 20 different implementations of the thing. But it's very aligned with that, right? So like each one of the centralized mutations you have corresponds to a field. You pass it stuff, the server does some mutations, and then you can query whatever arbitrary data you need after that.
Cool, thanks.
Yep.
Yeah, this might have been kind of answered, but I like the example when you took the mid-level API, you just stick it in the same data center, and one request comes in instead of all these. If you were actually doing that, would you probably need to eventually optimize that underlayer API if it was,
Absolutely, right? This is not like the long-term architecture. This is the way to like weasel in, to your org. So you like build this lightweight thing over a REST server, and then you show people graphical. They're like, oh my God, what's happening? And then your mobile developers start using that, and then it's an opportunity actually to like really build a much more optimized server. Okay, thanks for coming, everyone. Yeah, stick around. I'll be hanging out for a bit.